Students of second semester, uh, I hope you are all well and quite well in your own house. We now discuss today about your class that superposition of two perpendicular simple harmonic oscillations. That is superposition of two perpendicular simple harmonic motion. Now, it is a very important affair that here two simple harmonic oscillations, two simple harmonic motions act on a particle in two perpendicular direction. The resultant path followed by a particle under the influence of two perpendicular simple harmonic motion, and this type of two perpendicular motions when superimposed to each other, then the resultant motion sketch such figure. This figure is called Lissajous figure. Now we discuss about the mathematical expression of the two perpendicular simple harmonic motions and its superpositions. Now let us consider two perpendicular simple harmonic motions are gradually x equals a1 cos omega t. This is equation number 1, and anotherly y equals a2 cos omega t plus phi. This is the equation number 2. These are two simple harmonic motions. They act perpendicular to each other, and we need to superposition. We need to add them, and we want the resultant of these two simple harmonic oscillations. Now, to know the resultant path followed by the particle, we have to eliminate the time t from the equation 1 and 2. Now from equation number 1, we get x by a1 equals cos omega t. This is called 1a equation, and from this equation we can write that sin omega t equals root over 1 minus cos square omega t. We can write this about 1 minus cos omega t equals cos omega t equals x by a1. So x by a1, x square by a1 square, its square. Sin omega t equals this. This is the equation number 1b. these two equations, that is equation 1a and 1b, these are come from the equation number 1. So these are called 1a and 1b. Now putting these values, now putting, we are putting these values in equation number 2, equation 2, then it forms as y by a2 equals cos omega t cos phi minus sin omega t sin phi, or x by a1 cos phi minus root over 1 minus x its square and a1 square sin square phi sin square phi equals y by a2. Then squaring both sides, we get that, we have that y by a2 minus x by a1 cos phi its whole square equals 1 minus x by a1 sin square phi sin square phi. Then this mathematical expression of superposition of two perpendicular simple harmonic motion, we get that y square by a2 square plus x square a1 square cos square phi minus 2xy by a1 a2 cos phi. This is equal to sin square phi minus x square a2 square and it's sin square phi sin square phi. So finally we can get that x square by a1 square plus y square by a2 square minus 2y xy by a1 a2 cos phi equals sin square phi. This is very important equation. This is the final equation of superposition of two simple harmonic motions perpendicular to each other, and this equation number 3. Now we discuss about some cases, some special cases. Now from case 1 from this result, if phase difference between two simple harmonic motion is 0, that is phi equals 0. If phase difference